Hello everyone, welcome to my channel. This video is crystallography part 8 video. This video contains the derivation of Bragg's law. Now before the derivation of the Bragg's law, we have to know some basic thing about the diffraction, X-ray diffraction, which will be helpful for our derivation. First thing is that what is X-ray? X-ray is nothing but an electromagnetic radiation. Like visible light, X-ray is also electromagnetic radiation, and that's why X-ray undergoes diffraction. Another thing is that the wavelength of X-ray is too short compared to the visible light. That's why X-ray is not diffracted from the ordinary optical gratings. It is diffracted from the atomic electrons. And what is diffraction? Diffraction is the consequence of the constructive interference of the reflected beam. When an monochromatic X-ray beam is incident on an atomic electron, it will reflected, and this reflected beam can undergo both constructive and destructive interference. But we can see the diffraction when there occur the constructive interference, and this is very helpful for the derivation of the Bragg's law. Now Bragg's law is mainly at first we have to know what we study the XRD or X-ray diffraction, because the determination of the crystal structure of the system. For the determination of the crystal structure of the system, we need to know the XRD, and Bragg's law is related to the interplanar distance of the crystal plane. The interplanar distance of the crystal plane, Bragg's law is related. Now Bragg's law in 1912, W.H. Bragg and W.L. Bragg. W.L. Bragg is son of W.H. Bragg. They both put forward a model which generates the condition for diffraction in a very simple way. Condition for diffraction in a very simple way. W.H. Bragg and W.L. Bragg. Now Bragg's law, three parameters are involved in Bragg's law. These are the wavelength of the X-ray used. This is second thing is the glancing angle, that is the angle between the incident beam and the crystal plane, and third thing is the interplanar distance. From the Bragg's law we can calculate the interplanar distance, and Bragg's law is 2d sin theta is equal to n lambda. 2d sin theta is equal to n lambda, where lambda is the wavelength of the X-ray, theta is the glancing angle, and d is the interplanar distance. Now what are the interplanar distance? That is, these three planes are the parallel. These three planes are the parallel plane in a unit cell, and the distance between these two planes is the interplanar distance. This distance can be calculated from the Bragg's law if we know the wavelength of the X-ray, and it is known because what X-ray source we used, we know that, and for that we can obviously know the what is the wavelength of the X-ray source. And if we know the theta, that is glancing angle, we can calculate what is the interplanar distance or what is the d of this of those plane. Now the derivation of the Bragg's law. Let's assume these are the plane, and the planes are the parallel to each other. And the interplanar distance is d. D is equal to the PQ. PQ is d. Here d is equal to the P and Q. Now there is a ray 1 which is incident on this atomic electron and it is reflected back, and the glancing angle is the theta. As the incident angle is theta, so the reflected angle will be theta. This is the ray 1 which is reflected from this plane, and the ray 2 is reflected from the plane which is just below of the previous plane, and these two planes are parallel. This ray 2 is reflected by this atomic electron or atom, and the condition for the constructive interference is that the path difference, that is here LQ plus QM, will be equal to integer multiple of the lambda. Lambda is the wavelength of the X-ray used. It is the main thing for happen the diffraction or for happen the constructive interference. Now this is the ray 1 and this is the ray 2, and the glancing angle of ray 1 will be same as the glancing angle of ray 2 according to Bragg's statement, and the these two HKL values of these two planes are same because they are parallel plane, and in my previous video I showed you the what is HKL value and how to draw a plane and how they are parallel of having same HKL value. Now the HKL value of these two planes are same, and the glancing angle of ray 1 will be same as the glancing angle of ray 2. And another point is the diffraction is the consequence of constructive interference. This is very important thing. Now let's draw for the calculation of the path difference. The path difference is the LQM, and for this calculation let draw the perpendicular from P point to the incident beam of the ray 2 and also the to the reflected beam of ray 2. PL and PM are the perpendiculars drawn from the point P on the incident and reflected portion of ray 2 respectively. And here the path difference is LQ plus QM. LQ plus QM. And the condition for the formation of the constructive interference is the path difference will be equal to the integer multiple of the lambda value, that is the wavelength of the X-ray used, and here the integer multiple is the order of the reflection. For nth order reflection the path difference will be equal to n lambda, and for first order reflection the path difference will be equal to lambda. Now this is also a perpendicular, this is also a perpendicular. So from the geometry you can calculate that this theta will be same as the this theta will be same as the this theta, and this PQ is equal to D, this PQ is equal to D. So the LQ will be the this is theta, and this LQ will be the D sin theta, as the LQ is the PQ sin theta and PQ is D, so LQ will be D sin theta, as well as QM will be also D sin theta, and the path difference is the LQ plus QM, which is equal to D sin theta plus D sin theta, that is equal to 2D sin theta. Path difference LQ will be 2D sin theta. From the geometry you can easily calculate it, as theta is here, it is theta. This when we draw a perpendicular from this point, and this is also a perpendicular, then this angle will be also theta, and the LQ value is the D sin theta, as D the interplanar distance is denoted by D, and the LQ plus QM will be d sin theta plus d sin theta is equal to 2d sin theta, and for first order reaction it is will be equal to lambda, and for nth order of reflection then 2d sin theta will be n lambda for getting the diffraction, because the diffraction will only occur when the path difference will be the integer multiple of the lambda, where here integer multiple is the order of the reflection. For first order reflection 2d sin theta is equal to lambda, and this is the Bragg's law. This is the Bragg's law, that is 2d sin theta is equal to n lambda. If you know the order of reflection, the lambda value and the theta value, then you can easily calculate what is the value of the d. And if in the question n value is not given, then consider it as n is equal to 1. This is the complete derivation of Bragg's law. If you have any queries, you can ask me in comment section, and thank you for watching. If you like my videos, please subscribe my channel.